In this part of the presentation on the principles of option pricing, I discuss option premiums, lower boundary condition, exercise price of an option, and again we make mention of the effects of interest rates and volatility of the underlying stock's price. First, we talk about the difference in the option premiums in the premiums of two options. So the point here is that the difference in the premiums of two American call options that differ only by their exercise prices cannot be more than the difference in their exercise prices. So here's the expression that supports this statement. Now, to understand what this is saying, consider two options, option 1 and option 2. Option 1 is written on a stock whose price is 28. The exercise price of this option is 20, and this option is currently selling for $9 a pop. Now then, option number 2, which is also written on the same stock, selling for $20, however has a higher exercise price of 25. So what this statement is saying is that the difference in the call premiums of these two options cannot be greater than the difference in their exercise prices. In this case, the difference in exercise prices is 5. And we can see here that the difference in these two options satisfies this condition because the difference between the call option prices is 4. Now though, suppose option number 1 with an exercise price of 20 is selling for 12, and option number 2 with an exercise price of 25 is selling for 5. Again, notice the difference in their exercise prices is 5, but the difference in their call premiums is 2 more than the difference in exercise price. So this outcome does not support that statement, and if it doesn't, then it would open up this situation, this transaction, to some arbitrage opportunities. For example, let's say that at expiration the stock ends up at $30. Now what you would want to do, as we note here, is you want to sell option number 1. If you sell option number 1, you receive $12, and then you buy option number 2, in which case you'd pay only $5. Now what makes you know to sell and to buy, and which options to sell and buy? Again, the old dictum, buy low, sell high. So you want to sell this option costing $12 because it is selling at a price higher than it should, and then buy the one that's selling for $5 because all things considered it is selling lower than it should. So with that, if the stock price again expires ends up at 30, then the option that you sold, which is option number 1, would fetch you a profit of $2. Again, remember, if you're the writer of the option, then the intrinsic value becomes a negative to you. Watch my arrow here, the pointer, and you received the call premium. So if you put in the numbers, you're going to get a gain of 2. Now on the other hand, the option that you purchased, option number 2, this intrinsic value here is your money to keep. Alright, so 30 minus 25 is your money, which is 5. However, remember you paid $5, so minus 5, which is what you see here, you wind up with nothing. However, put the two together, you have a total profit of 2. Now here I chose an ending stock price that's greater than each of these exercise prices. Now again, say the stock price expires at 7. Now, well, I do want to say if the stock price ends at 7, the stock does not expire, the option does. So if the stock winds up at 27 upon the expiration of the option, on option number 1 you're going to make 5. Again, because 27 minus 20 will give you an intrinsic value of 7, but since you wrote the call, it's a negative 7. but you receive 12 from selling this call. So put the two together, that's a gain of 5, a net gain of 5. For the option number 2 that you sold, 27 minus 25 is your intrinsic value of 2, minus the 5 that you paid to purchase this option. You have a net outcome of minus 3. So positive 5 minus 3, you're still enjoying $2. For any price that you choose above 25, you're going to find out that your cumulative profit would be 2. So that's an assured return, net gain on this transaction. If I were to choose a price though that's less than less than E2, 24 for example. Now option number 1, which you sold, what happens here is that if the stock price is 24, intrinsic value would be 24 minus 20, which is 4. But since you wrote it, it's a negative 4 to you. Plus the $12 you collected from selling the option, you have a net gain of 8. On the other hand, for the option that you purchased, 24 minus 25 gives you an intrinsic value of 0. So 0 minus 5 leaves you with minus 5. Yet, put the two together, your total gain is even larger. For any price 24 and going down, you'll find that your gains will continue to rise. And so this is an assured profitable outcome when the difference in the call premiums between two options differing only with respect to their exercise price exceeds that difference in exercise price. Next concept is the lower bound condition of a European call. Recall that earlier we talked about the minimum value of an American call, which says that an American call would be that its intrinsic value would be either 0 if it is out of the money or S minus E. The point to note here though is that while an American option can be exercised at any time so that E is effective at any given time between now and when the option expires, for a European option E isn't effective until at option's expiration. Therefore, prior to expiration, we can only view E in present value terms, and that's what you see right here. So S minus the present value of E defines the lower bound condition, which, if it isn't positive, then the 0 condition would prevail. So this is what's called the lower bound condition, or if you like, the lower boundary condition. It says that the lower boundary value for a European option would be the greater of 0, or this expression here, the stock price minus the present value of the exercise price. Now though, look at this numeric example up here. Suppose the stock is selling for 12 and exercise price on the option is 10. Risk-free interest rate is 4%, and this option expires 6 months from today. Now first of all, look over here. If we were to calculate the minimum value of this option, if it were an American option, that minimum value would be S minus E, which is S minus 10, which is equal to 2. Now hold that thought, that the minimum value for this option, if it were an American option, would be 2. Now let's calculate the lower boundary condition, given that this option is a European option. First of all, we need to get this value here, the present value of the exercise price. Now writing it in more conventional form, that's it right here, E divided by 1 plus R to the T. So if you discount the exercise price, again making sure that 1 plus 4% is discounted over half a year, since it's a 6-month option, we find the present value of this exercise price of 10 to be 9.81. So think about this. If we take 9.81 and place it right here for the present value of E, and then put the value of S here, which is 12, you see 12, you put it right here. 12 minus 9.8 would leave us with a value of 2.19. So 2.19, which is the lower bound value of a European option, comes out to be larger than the minimum value of an American option, which we determined earlier to be just 2. So then you ask yourself, how can it be that the lower boundary value for a European option is larger than the minimum value of an American option? Think about this for a second. In case you have forgotten, remember, an American option is one that gives you all the benefits of a European option, in the sense that if you buy it, you can choose to hold it until expiration. But if you want to, you can also exercise it at any time prior to expiration. So since an American option gives you everything a European option gives you and then some, why would it have a value that is less than the lower boundary value of a European option? In this our example 2 versus the lower bound value of 2.19. It cannot, and therefore we indicate that since an American call is at least as valuable as a European call with identical terms, it follows that the lower boundary condition also applies to an American call. And that's where we park our car. Now, how about the lower boundary value of a call written on a dividend paying stock? Now, the only adjustment we're going to have to make here is S, and let's say that the lower boundary value would be the greater of 0 if the option is worthless, or the difference between S star and the present value of the exercise price. So this is all things we've seen before, except for S star, which is simply the stock price S minus the present value of the dividends that would be paid. Remember, a dividend paying stock falls in value on the ex-dividend date. So we need to adjust the stock price by the present value of the dividends that would be paid. So if, of course, today or a few minutes or a few hours from now is the ex-dividend date, then D would be approximately equal to the present value of D, since the date that this dividend is effective is at hand. Remember, the ex-dividend date is the date that the right to receive dividend elapses. If you don't buy the stock prior to the ex-dividend date, you will not receive dividend when it is eventually paid. Now, here's an interesting point to note: the early exercise of an American call. Remember, an American call is one that can be exercised at any time up until expiration of the option. And the question here is, because of that extra benefit, should an American call be exercised early? And the categorical answer here is no. And this answer is categorically no only if the stock does not pay dividends. First, let's explain why an American option should not be exercised early. Note that if you exercise an option, an American option, at any time, the intrinsic value of S minus E is what you would receive. If the stock price is 20, exercise price is 15, you would receive 20 minus 15, which is 5. That's how much money you will pick up, net of whatever money you paid to buy the option. But this is your intrinsic value. Now, if on the other hand you sell the option, you'd receive C. So if I were to go back to an earlier example which I gave, let's look at option number 1, for example. Stock price is 28, exercise price is 20, call option is 9. Notice, if you were to exercise this option, your intrinsic value would be 8. 28 minus 20. That's how much you would receive from exercising this option. Now, if on the other hand you say to yourself, I don't want to exercise this option, I'm instead going to sell it. Let's say this option still has about a month prior to expiration. If you sell it, you'd actually be receiving $9. So here's the deal. Would you prefer $8 or 9? You'd get 8 if you exercise it. You'll get 9 if you sell it. So surely you wouldn't want to exercise this option. You'd instead want to sell it and keep the option alive. You might say, well, maybe it is convenient that I chose a call premium example here that is greater than the intrinsic value of 8. And I actually have explained this before. Because this option still has some time prior to expiring, you can expect it to sell for at least its intrinsic value. Indeed, you can expect it to have some sugar on top. That sugar on top, in this case $1, is reflecting the time value of the option. You still have about a month prior to the option expiring. And that additional value called time value is what would cause you to want to sell this option instead and fetch yourself a little bit more money than exercising it. So that's the point mentioned here. Now though, we want to note that there might be a situation where you could consider exercising an American option early, and that is if the option is written on a dividend paying stock. So that's the title of this one here, the early exercise of a dividend paying American call. Now, option on a dividend paying stock may be exercised early. Now this is why, and I'm just going to give you the basic precepts to this. Remember, on the ex-dividend date, the stock price would drop, often by the amount of the dividend, because you know, if a stock is selling for $20 and dividend per share is $2, on the ex-dividend date you can expect the stock to drop from 20 to 18, because no one is going to want to pay the same $20 to purchase a stock that would not pay him or her the dividend of $2. So you can expect the stock price to drop. And of course, if the stock price drops, as we have shown already, the call premium would also go down. And we can expect it to go down by no more than the $2 of dividend per share. So it's going to be $2 or less. Now though, the investor could avoid this loss, alright, regarding the value of the call by exercising the option immediately before the stock goes ex-dividend. There you go. So if you exercise the stock prior to it going ex-dividend, you would still enjoy the intrinsic value before the stock's price adjusts to the dividend that would now elapse when the ex-dividend date strikes. So in effect, the drop in the call premium should be compared to the prevailing intrinsic value of the option. Remember, the intrinsic value is what you would receive if you exercise the option, and the call price is what you would receive if you sold the option. So the question is, which one would get you more money given the effect of dividends? So there is more on that argument that could be discussed in a different circumstance. Now finally, we note here when early exercise of an option is not optimal. Now we note here that the right to early exercise has no value in general if the present value of all expected dividends is less than this expression here, which is really the difference between the exercise price and the present value of the exercise price. Now this amount here, this exercise price and its present value, this difference here is simply denoting the interest income you would receive by keeping your money in the bank in the meantime, pending when the option expires, and you then go withdraw the money to purchase the stock through the exercise of your option. Remember, if you own a call, when you exercise it, you'd have to pay E dollars. If E is $20 per share, you'd have to pay $20 per share to take possession of the stock since you have exercised your call. So the question is, what should you do if your option is written on a dividend paying stock? Remember, if you exercise early, you take possession of the stock and then you would be receiving the dividends promised on that stock. Now, if on the other hand, you do not exercise that option early, then you will keep the you'll keep your call option alive until expiration. By keeping it alive until expiration means that the exercise price money would stay in the bank pending the expiration of the option. So between now, when the stock is about to go ex-dividend, and let's say, for example, 1 month from now, or maybe let's make it better, 6 months from now, when the option expires, how much interest would you collect on your exercise money, which is held in a bank, between now and the next 6 months? So consider the interest you would earn on your exercise money, which won't be paid until 6 months from now. Your total interest income on that money held in the bank, let's say it comes out to be $15. Then compare that to how much dividend income you would be paid if you exercised your call option today, take possession of the stock, and then receive the dividends that the stock promises. If those dividends come out to be an amount less than the $15 of interest income, then you really shouldn't want to exercise early. If the present value of the dividends is, let's say, $13, while the interest income is 15, do not exercise early. Why get 13 when you can get 15? And that's a way to wrap this up, except that down over here we note again that the comparative statistics, the relationship between call price and interest rate, is positive, because as you see here, if you keep your money in the bank until expiration earning 5%, you would have a greater incentive to even buy a call and continue to and wait until expiration if interest rate were to be twice as much, say for example here 10%. Remember, the higher the rate of interest, the more the interest income you would get on your exercise price money held in the bank. If on the other hand you were to buy the stock right now and forget about buying a call option on it, then you would have used up the money now to own the stock. So what would incentivize your decision to buy a call which gives you the right to buy the stock at some point in the future? It would be rising interest rates, because as interest rates rise, paying $2 to buy a call that gives you the right to then pay $50 to buy a stock 1 year from today would be much more attractive, because you'd be getting paid a higher interest of 10 than a lower interest. So the higher the rate of interest, the greater would be the benefits that you would receive from your interest income on the $50 that you put away in a bank for 1 year, pending when the option expires, and then you go ahead and buy the stock. And we already have explained the fact that volatility is sweet nose to an option. The more volatile a stock, the greater would be the value of an option, because you have nothing to lose if volatility forces stock price in the wrong direction. You simply lose no more than the premium that you paid. On the other hand, if the price surges in the direction that you seek, then you'll make a lot of money in the derivatives market. And this concludes this segment of my lecture on the principles of option pricing. My name is Pat Obi, Professor of Finance at Purdue University, Calumet.